Hello, Math 7, coming back to you with a new lesson for you guys. Now, if you need, I recommend going back through the other problems, or rather the other videos, so that way this will make sense. Today we've been talking about equations, different expressions, and things like that. Today we're introducing a new form of equation, problem, ways to describe things. These are inequalities. Now, this prefix in means that it's not equal. So inequalities do not show equality. They show some things that are unequal. You'll recognize some of these signs that as we go through them. You'll recognize this one as less than. So this less than sign is a type of inequality. There's several of them. Another one is greater than. You'll recognize that as well, right? These ones, the alligators eating all the stuff on the right-hand side rather than the left-hand side, which is opposite of the greater sign or greater than sign. Then we have less than or equal to. So that means that the stuff on this side of the equation is less than, or it might be equal to the stuff on this side. Another way to describe that is at most or maximum. So this is at maximum that, or this is at most that. Yes, you will need to know the different phrasing for your test that's coming up. I recommend writing these down. We also have greater than or equal to. That would mean this is greater than or equal to that. This is at least that, or this is at minimum that. Again, we've got these different phrasings that you'll see there. The only difference, of course, between the greater than sign and the greater than or equal to sign is this line underneath. Yes, these lines underneath are significant, so make sure you keep note on that. There is one more, and it's just simply not equal to. So it's the equal sign with a slash through it. That's saying that this over here is not equal to this over here. Okay. I do have plenty of examples. Yes, these do involve word problems. So we're going to take it slowly, but we're going to get through it. Okay. Write an inequality for each sentence. So again, these are word problems that we will just use these signs to represent the different expression. Okay. This is saying the sum of n and 9 is at least 12. So we know at least is talking about this sign here. So again, I'm going to form my whole numerical sentence around my inequality in this case rather than my equality or my equal sign. So I'm going to write down this greater than or equal to sign. And sum is going to be n plus 9 is greater than or equal to 12. Or in this case, I switched them. 9 plus n is greater than or equal to 12, which works out just fine. Okay. We're not going to worry about solving them today. Today we're focusing on how to write these. Okay. Here's another one. A number, we don't know what that number is, so we're going to just use a variable there. A number less than 3 is less than 5. Okay. Now, notice how I don't have the word is. So, no is. But here, I have the word is. This is my key. That's where I'm going to put my sign. So, put your sign. Wherever you see the word is, that's where you're going to put your sign. Oh, that says sigh. Put your sigh. No, that's not what we're doing. We're putting a sign. I hope you guys are entertained by these videos and some of my little mistakes. Okay, so a number less than 3. So remember, than, this is where we switch things around. So less is the operation, that's subtraction. So 3 minus a number is less than 5. Okay. So it has been a couple weeks since we've done math. This might seem like, whoa, way quick, but it's just one step at a time. All right? Okay. I have some practice problems here for you, and I think you guys will be able to do that. Okay, so what we're figuring out is for which of these inequalities is 15 a solution? So where can I put 15 in the variable to make it a solution? Let's just take one at a time. Hold on, let me get a, where's my handy dandy little, oh, here it is. Okay, so I'm just going to put this here so that way we don't need to worry about that. Okay, so for this first one, 2 plus 5x is less than 15. Okay, that 15 doesn't have to do with this one in the question. It means that I'm going to put that in as my variable. So 2 plus 5 times 15 is less than 15. Okay, well, 5 times 15 is 75. Is 2 plus 75 less than 15? No, 2 plus 75 is 77, which is not less than 15. So no, 15 is not a solution, not a number for which we can put in our variable. Okay, let's go to this one. Okay, number 2. 3 times x minus 13 is less than or equal to 6. Okay. So again, I'm going to put 15 in for my variable. 3 times 15 minus 13 is less than or equal to 6. Well, let's figure that out. So order of operations, I need to subtract. I need to take care of my parentheses before I can multiply. 15 minus 13 is 2. 3 times 2 is less than or equal to 6. 3 times 2 is 6. And it is true that 6 is less than or equal to 6. So this makes the answer true, or the inequality true. Okay. Now, if we were on a number line, there will be times where we have to graph. If you see less than, greater than, or not equal to, you make an open dot, which looks like that. No, that's not the face. That's like, oh, I can't believe they did that. No, that's not what we're talking about. That's not what we're talking about. Okay. You'll just see an open dot at the number. But if you see less than or equal to, greater than or equal to, or equal, you make the dot closed. This is what we're used to seeing, what we're used to using is closed dots. But now, if it's any of these three, you just make that dot open. Don't worry, I've got plenty of examples. So let's say x is greater than or equal to 4. So I'm going to draw out my number line, right? And we've just got a regular old number line. So I'll just do an example here. I've got a regular old number line. I'm going to include 0, 1, 2, 3, 4, 5. So here's 4. Negative 1, 2, 3, 4, 5. There's negative 4. So it's asking for greater than or equal to. So I know it's going to be a closed dot right here at 4. But because it's greater than or equal, what I want to see is this. So yes, I have my number line. I have my closed dot at the number, and it's closed because the equal line. But I need an arrow pointing this direction, because all of these numbers are greater than 4. It's closed, meaning that it's equal to 4 as well, but x can be 4 and all these numbers greater than that. Also, I'll just say also. Okay. Here's another one. X is less than -3. So again, I've got less than -3. I'm going to come to my number line. -3 is here, but it's just less than, not equal to. So I'm going to have an open dot at 3. That's a little bit big, but I'm just trying to emphasize. And because it's less than, all of my numbers are going to be that way. My answer is going to look something like this. Okay. So I've got a number line again. 0 in the middle, 1, 2, 3, 4, -1, 2, 3, 4. I could just stop at -3, but I wanted to emphasize. Again, I'm going to have an open dot at the number, and my arrow is pointing to all the other numbers. Right, your arrow points, I'll say that. Let's see, how can I do this? Arrow points to all other numbers. All of the numbers that make inequality true. So if x was -5, -5 is less than -3, so therefore it's true. Okay. I hope all these notes make sense. I'm adding extra notes because I can't be there with you guys to teach you, so I'm just trying to go over and above. Okay. Now we're going to practice graph. So this first one's going to be n is greater than or equal to 2. You could go ahead and pause that, or just wait till I expose it. You could also see through my paper. Oh no! That's fine. I'm actually just going to expose all of these, and then I'll explain a couple of them. So 2 and 3 should make sense because those are the ones we've been going over, but I want to explain number 4. So x is not equal to 2, the number 2. That means that x equals every number except for 2. So I'm still going to draw my number line. At where 2 is, I'm going to draw that open circle because it's not equal to it. And then I'm going to have lines going either direction because x could be it could be 1, 3, a billion, -1 billion. It could be all numbers except for 2. Okay? Hope that makes sense. All right, we're going to move on. We're going to tell whether the given value is a solution. So this first one, 3x minus 5 is greater than 17. But we're going to solve it for x equals 6. So we're going to plug in this value. 3 times 6, 18. 18 minus 5 is 13. Is 13 greater than 17? No. Okay. 17 minus 5n is less than or equal to 35. Well, when you subtract negative 5 times negative 2, you get positive 10. 17 plus 10 is still less than or equal to 35, so the answer there is yes. 17 plus 10 is less than or equal to 35, making the answer yes. Okay. Please write an equality. 5 times a number is at most 20. Oh, I have another one for her. Jane has set a maximum price of $50 for a new dress. So for this first one, 5 times a number is at most 20. So it's going to be less than, it might be equal to 20, but it's going to be less than that. Less than or equal to. So 5 times the number 5n is at most, so it can be less than that. It can also be equal to 20, our number. And number 2, Jane has set a maximum price of $50 for a new dress. So she can spend $50, but she'd rather spend less. So the new dress is going to be represented by n, our variable, less than or equal to 50. Okay, guys, this is a tough section. So this video is a little bit longer. I hope it helps. Please comment below, send me an email. I've got a lot of grading to get done today, so I hope to reply to your email promptly. Please have patience with me. Otherwise, love you guys a bunch. I'll talk to you later. Bye.